Hello, I am Ujjwal Sekhar and I am from first batch of Abharan Super 30. I am here to discuss about Euler's theorem, Fermat's theorem, Lagrange's theorem. So, before discussing the main topic, I will go through the prerequisite. You can say these concepts you should know before attempting to these theorems. So, I will make you understand the what is congruency, what does this expression mean, and all. Let's start with this expression. So this is an expression. This is an congruency symbol. Yeah. So this is a congruency symbol. Let me go through the. Yeah. So this is a congruency symbol. So what it says is that if we have an integer a and an integer b, uh, and then an integer n which is greater than 0, so it is necessary that n should be greater than 0. It can't even be 0, right? So we can say that a is congruent to b modulo n. So this is how we read it. And in simple meaning, you can simple words, you can say, if you are given some expression and you have to check whether it is a correct expression or not, you can simply write, simply check, simply do some steps like subtract a minus b and divide it by n. If it is a divisible by n means it will give a whole number. Then the given expression is correct, right? So for example, you can see we have to check if 29 is congruent to 8 modulo 7 or not. So what we did is that let's this is my a, right? This is my a, this is my b, and this is my n. You can write it like this also. So this now we have to check. So what we will do is we will subtract 29 minus 8, and the output will be 21. Now if we will check if 29 is divisible by 7 or not. So yeah, we are getting a whole number, right? So it is divisible by 7, so we can say this is a correct expression. Yeah, so we can say this is a correct expression. Now let's check for 8 29. 8 is congruent to 29 mod 7. So again, now this is same expression only, but the a and b are exchanged, interchanged, you can say. So we have 8 as a, 29 as b, and n as 7. So what we will do, we will subtract 29 from 8, and the output will be minus 21. So after dividing minus 21 by 7, we will get minus 3. So again, you are getting a whole number. Even if it's a negative number, negative numbers are also a whole number. So we can say that this is again a correct expression. Let me correct my meaning. This is again a correct expression. So now let's check for any random number. You can say, uh, yeah. So random. Let's say I am taking 57 is congruent to 57 is congruent to, let's say I'm taking 21 mod random 6. So let's check if it is a correct expression or not. So what we will do, we will subtract 21 from 57. So the output will be 36. Again we will divide 36 by 6, and the output will be obviously a whole number. So again this is a correct expression. So let me take a wrong expression. So what we can do, let's say I'm doing it 23 here. So now my b is changed to 23, and my output will also change to 34. Now if we will divide 34 divided by 6, what it will do, then I will get 5.6667. So this is not a whole number. So you can say that this is a wrong expression, right? So this is how we check if it is a correct or wrong expression. So again, if it to make it a correct expression, either you will have to select a b which is giving you a whole number, or you can also use this expression. This is called incongruent to. And for this example, you can see we have a as 23, b as 8, and 7 as n. So the when after subtracting I am getting 15, and after division this is not a whole number, so it is incongruent to. This is basically not congruent to. So not congruent to is called incongruent. Yeah. So again I have an expression, 60 is equivalent to 0 mod 15, right? So we will do 60 minus 0, and this is all you can practice with any number and check if it fits in the expression or not. Now let's see, I am giving you an expression, general expression: a is congruent to b modulo 1, right? So what exactly we will do? So obviously a and b are integers and 1 is greater than 0, so this, so we can check for the congruency relation. So what we so here we start with a minus b. So after subtracting b from a, we will also, the result will also be an integer, right? Because a and b are integer, their subtraction will also be an integer, and we know that every integer is divisible by 1, right? So so we can say that in general we can write this expression as correct with any a and b. For any a and b, let's say we are taking 23, let's say we are taking 29 is equivalent to 34 mod 1. So this is also correct expression. You can see 29 minus 34, we will get 29 minus 34 minus 5, and minus 5 is divisible by 1, minus 5 times. Yeah. So we can say that this is a correct expression, and this holds true correct for every a and b. The till a and b are integers, this is correct. So this is how we can uh, this is an expression you can remember, like if every time you are getting n as 1, this will be a correct expression, right? So how we will represent even numbers? So even numbers, so definition of even numbers is that the number should be divisible by 2. So for division, what the division part comes to n, right? So we will keep 2 as n, and and check if a minus b is divisible by 2 or not. If a minus b is divisible by 2, and obviously if we are getting a whole number, then a is an even number, right? You are getting, if a is an even number, and a minus b is divisible by 2, then this expression is true. For odd numbers this is not true. So you can see how I am generating a general equation. This is a general equation for any a and b, as an integer, and this is a general equation for a b an integer in such a way that a is an even number. If a is an even number, then this is always true. if A is an even number, then this is always true. Yeah. So similarly, you can see, and B is also an even number here also. B is also an even number, and for example, you can see 4 minus 2 is 2, and 2 divisible by 2 one times. So you can say this is how we can represent an even number. Similarly, to represent an odd number, we can say A is congruent to 1 mod 2. So every time we will divide a number by 2, if we are getting a remainder as 1, so you can say it like that. Every time we are getting a remainder as 1, you can say that that number is odd number, right? So this is how we will represent an odd number in congruence relation. And one more thing I want to say is that let's say you are given an expression A is congruent to B mod n. So if this is a correct expression, if this is a correct expression, then uh, then uh, this is also a correct expression. Why? If A minus B is divisible by n, then B minus A is also divisible by n. So it is common sense, right? If 4 minus 2 is divisible by 2, then 2 minus 4 is also divisible by 2. So this is how uh, you can understand what is congruence. So uh, yeah. So now we will be going through residue system. If there is an expression which says that x is congruent to y mod m, then we can say that y is residue of x modulo m. Yeah. So in this example, you can see 26. I have written 26 is congruent to 1 mod 5, and after checking if it's a correct expression, we can see we are getting whole number. So we can say that one is residue of 29 more below 5. So in general, we can say that if you are given some m, so irrespective of what number you are getting, so you know that this all will be in the remainder part. So whatever remainder you can get from any m, that will be included, in the residue system. So obviously for m equals 8, we can divide any number by 8, and the remainder will be less than 8, and it can't be negative. So obviously we will not cover the negative part. So remainder can be 0, 1, 2, 3, 4, 5, 6, 7, and yeah, 0 to 7. Now let's see if it is yeah. So this is a residue system. So this all will be included in the residue system. Now there are two parts of residue system. So parts are basically divided based on whatever x I am getting, right? So it changes because of x. So there are two parts. One is complete residue system, and another is reduced residue system. So let's say I'm writing a residue system. We have our previous example was 29. 29 is congruent to 8 mod 7. So this is a correct expression as हमने देखा है पहले. So you can say 29 is congruent to 8 mod 7. So Again, we can say that 8 is residue of 29 modulo 7. Again, let's say I'm writing another expression which is 29 is congruent to 1 mod 7. So here we can say that if it is the correct expression or not, we can check by simple arithmetic. So it is 29, sorry, 29 minus 1 equals 28, and 28 divided by 7 gives me 4. So this is a whole number. So we can say that this is a correct expression, and because this is a correct expression, we can say 1 is residue of 29 uh, below 7. So here what you are getting, again one deduction I want to do. So this all you have to keep in mind. 8 is residue of 29 mod 7, so this number should be included. 8 should be included in the residue system. 1 is also a residue of 29 mod 7, so 1 should also be included in the residue system. Again let me take another example. 8 is congruent to 1 mod 7. So is this a correct expression? So obviously you can say 8 minus 1 is 7, and then 8 minus 1 equals 7, and 7 is obviously divisible by 7 one time. So you can say that this is a correct expression. Now while writing reduced complete residue system, we have to keep in mind a simple thing. This all should be included. 8 should be included in residue system, 1 should be included in residue system, but both of them can't be included in complete residue system. So let's say I'm writing uh, 1 in a residue system of 29 modulo 7. We can't write 8 over here in the same residue system, in the same set, right? Because we have to check for one condition. If 8 is also in same set, 1 is also in same set, it should not follow this condition. If this is satisfied, 8 is congruent to 1 mod 7, 8 is congruent to 1 mod 7, then you can't include both of them in the same set. So this is how it changes in complete residue system. So by definition you can say this is a set of integers such that every integer is congruent modulo m to exactly one integer of the set. So what it says is that complete residue system, all in complete residue system, all the integers should be congruent modulo m to exactly one integer. And so here you can see I have one integer as 29. Let's say I have a set in which I am including both of them in the complete residue system, and I have an integer 29. So we can say that 8 in from the system, we can say that 8 is co- congruent to 29 modulo 7. Again 1 is also congruent to 29 modulo 7. So this is not unique. That's what it is saying. It should be a set of integers such that every integer is congruent modulo m to exactly one integer of the set. Every integer here, every integer is 29, and it should be congruent to exactly one integer of the set. This is my set, and this 29 is congruent to two integers of the set. So this is not a complete residue system. So this is not a complete residue system. Yeah. So this is how we have to understand what is residue system. Again you can see this is not equal to this. Yeah, incongruent. So if this is followed, then obviously you can say This is a complete residue system. Yeah. So I think you got it. Like what is complete residue system? So for 4, you can write it as 1, 2, 3, 4 is also a residue system. Again, you can see like it's not important that we have to write it like this only. Let's say this is a residue system. This is also a complete residue system by mistake, but it is a complete residue system. So if I am writing it as 29 or let's say m equals 8 only, 2, 3, 4, 5, 6, 7, 8. Let's say I'm including 8. So what it does is that in the same manner, if 8 mod 7, 8 and 1, right? Irrespective of whatever integer I am taking, 8 and 1 both are in same set. So this can't be a complete residue system. But this is a residue system, not complete one. So this is a complete residue system. The other one is reduced residue system. So this is a extension of complete residue system. So the only thing you have to make sure is that if you are getting a you have to find reduced residue system, just find the complete residue system and uh, pick all those numbers. Let's say I have from 4 I have let's say from m equals 8 only, we have complete residue system as 0, 1, 2, 3, 4, 5, 6, 7. So from this we have to remove all those integers which are not prime to 8. It means it should only include those integers, only include those integers which are co-prime to 8, right? So after removing that, you can see we have 1, then you have 3, then you have 5, then you have 7. So all those have 0, 2, 4, 6, all those have a GCD which is greater than 1. So they are not co-prime to 8. And yeah, so this is a definition of reduced residue system. So this will be a reduced residue system, and this is from a complete residue system. Yeah. तो अब एक थ्योरम देखते हैं. This theorem says that let's say we have a and m as integers and GCD of a comma m equals 1. Let's say they both are co-prime and there is a reduced or complete residue system r1 comma r2 comma r3 dot 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 n, right? So we have this complete or reduced residue system. Then it is saying that if this is a complete or reduced modulo system, then AR1 AR1 AR2, it means A star R1. You have to understand A star R2 and A star R3 up to uh, A star Rn. This will also be a complete or reduced residue system modulo M. So now we have to prove it. So लेट्स से हम अज्यूम करते हैं कि ये मेरा रिड्यूस्ड या कंप्लीट रेसिड्यू सिस्टम नहीं है, तो सबसे पहले हमें क्या प्रूव करना होगा? सो द ओनली थिंग जो हमें प्रूव करना होगा वो ये है कि इट मीन्स दैट ए स्टार आर वन is, sorry, I have to take the congruency symbol. A star R1 is congruent to uh, A star R1 is congruent to A star R2 mod M. Yeah. So if we are getting two numbers from this set in such a manner that this is a correct expression, then we can say that this is not a complete or reduced residue system. So basically we are taking a contradiction that we are assuming that this is not a complete or reduced residue system, assuming that given set is not complete or reduced, complete or reduced. सो अभी अज्यूम करने के बाद सबसे पहले हम लोग ये करेंगे, सो आई हैव टू चेक कि ये करेक्ट है कि नहीं। अगर ये करेक्ट है देन आवर अजम्पशन इज करेक्ट, इट मीन्स ये कंप्लीट या रिड्यूस्ड सिस्टम नहीं। अगर ये करेक्ट है तो हम लेट्स से वी आर नाउ वी विल राइट इट एज अ जनरल ए स्टार आर आर आई आर आई ए स्टार आर आई is congruent to A star Rj mod M. So what it says, इसका मतलब क्या है कि हमारा अगर ये एक्सप्रेशन करेक्ट है, इसका मतलब A स्टार आर आई माइनस ए स्टार आर जे, अगर ये निकालते हैं या सो दिस शुड बी डिविजिबल बाय M, राइट। सो इसका मतलब क्या है कि इस शुड बी डिविजिबल बाय N, it means that A into Ri minus Rj is divisible by M. So अभी हम लोगों को एक कंडीशन भी दे रखा है, GCD of A, M equals 1. It means that M will not divide A, क्योंकि M और A खुद एक को प्राइम नंबर्स हैं। So obviously हम लोग A और M को डिवाइड नहीं कर सकते। तो अगर यहाँ पे कोई को प्राइम नंबर है और एक कोई और नंबर है यहाँ पे जिसको मुझे m से डिवाइड करना है, तो ऑब्वियसली ये श्योर होना पड़ेगा कि ये ज़ीरो हो। ये तभी पॉसिबल है जब हम a इंटू ज़ीरो को डिवाइड करें m से, क्योंकि a क्या है, a एंड m आर को प्राइम, सो दे कांट डिवाइड ईच अदर आइदर वे। So from here we can say that Ri minus Rj equals 0, and so from here we got Ri equals Rj. So this is a contradiction, right? It means that if you are saying that A into R1 is congruent to A into R2 mod M, then A into R1 is equal to A into R2. It means they both are same numbers. If you are saying that, so they both have to be same numbers, but what we assumed was this is two different number and this expression is correct, it means it is satisfied. So we got a contradiction from here, so we can say that our assumption was wrong, and hence this is a and hence this is a this and hence is a complete or reduced is a complete or reduced system modulo n, modulo m, right?